Conjoint analysis is a technique for understanding how people evaluate the relative importance of various attributes of a product or service, such as the design or the price. The main purpose of the analysis is to determine which set of attributes yield the highest overall preference. It works by showing people a representative set of items with different attribute combinations, such as different colors or designs or price points, endorsements, or money-back guarantees. Each combination is then ranked by the respondent in terms of their preference. Conjoint analysis usually begins with researchers generating what's called the design file. And this is where a list of attributes for the product is created, but not every possible permutation of attributes. The reason this is done is because showing people all possible product combinations is not very practical. There's simply normally too many of them. So the reduced set of possible products with different attributes is small enough to include in a survey, but large enough to assess how important each attribute is. After creating the design file, you can run the display command to create the individual product profiles that will be shown to survey respondents for rating. These profiles are often referred to as cards. When showing the subjects the various product cards, you ask them to rank the profiles from lowest to highest preference, and then enter their preference ranks back into SPSS statistics for analysis. When running the conjoint analysis, you'll find that it actually provides a lot of useful output. It shows, for example, the relative importance of each attribute. It provides simple weightings to calculate the overall preference score for each combination of attributes. It shows how strongly each of the factors are correlated with the overall preference scores, and it indicates any subjects where the scores of certain attributes were counterintuitive, for example where lower prices were seen as less desirable. But conjoint analysis is particularly powerful when we're playing around with simulated cases, i.e. when we create product combinations in order to estimate the preference scores they would likely receive if they were shown to respondents. Here we have, for example, 4 simulated cases, each of them separate from the other because they've got a different combination of attributes associated with them. When we run the conjoint analysis on the simulated cases, it gives us 4 different preference scores, and the one with the highest preference score is combination or card 2.